Witness the incredible assembly of giant cranes, power, and engineering mastery coming together to lift the impossible. The Liebherr LTM 400-ton all-terrain mobile crane is a remarkable example of engineering excellence, combining exceptional lifting capacity, advanced hydraulics, and mobility. This Sieben-axle crane is designed to handle heavy lifting tasks across various industrial and construction sites. With a maximum lifting capacity of 400 metric tons and a telescopic boom that can extend up to 60 meters, it is capable of performing a wide range of demanding operations. Its versatility lies in its modular configuration, allowing for quick assembly and disassembly, while maintaining stability and precision during heavy lifts. To begin the installation process, the crane itself is positioned on a level and firm working surface, ensuring maximum stability during setup. Outriggers are extended, and the chassis is leveled to provide a solid base for the upcoming operations. The Y-guying system, which consists of a Y-shaped support structure mounted on top of the boom base, plays a vital role in maintaining the rigidity and stability of the telescopic boom during lifting. Once the work area is properly prepared, the Y-guying system is brought close to the crane using its own lifting mechanism. Unlike smaller cranes that require auxiliary lifting equipment, the Liebherr LTM 400 utilizes its hydraulic power to lift and position the system autonomously. This self-erecting capability is one of the hallmarks of Liebherr engineering, reducing the need for additional cranes and saving valuable setup time on site. The operator begins by carefully extending the boom to an optimal angle that allows the Y-guying system to be lifted from the ground. Using precise hydraulic controls, the crane's hook is attached to the lifting points of the Y-guying frame. Slowly and steadily, the system is raised from the ground, while rigging personnel monitor its movement to ensure balance and alignment. During this phase, communication between the operator and ground crew is critical, as even minor misalignments could affect the centering of the structure. As the Y-guying frame is lifted, it is guided toward the top of the crane's chassis, where it will eventually be mounted. The operator adjusts the boom and winch speed delicately, ensuring the system remains stable during the hoisting process. Once the Y-guying system reaches the correct height, it is carefully positioned above its mounting point on the chassis. This step requires precision because the alignment pins must fit exactly into their respective holes to secure the frame. When the system is properly aligned, the crew proceeds to lower it slowly onto the chassis. The Y-guying structure is then centered manually by guiding rods and visual markers, ensuring it rests perfectly in place. Technicians check that the frame sits symmetrically on the chassis, as any deviation could affect the boom stability during future lifting operations. Once aligned, the frame is pinned securely using heavy-duty locking pins that connect it to the crane's base. These pins are inserted manually and locked to prevent any movement during operation. After pinning, the hydraulic connections between the Y-guying system and the main boom are inspected and attached. The hydraulic lines provide the power needed for the guying system to tension and support the boom during lifts. Technicians verify that all hoses are correctly connected and that there are no leaks or blockages. The electronic sensors and control lines are also checked to ensure that the system integrates seamlessly with the crane's onboard computer, allowing the operator to monitor and adjust tension levels during operation DDWay. Once the mechanical and hydraulic installations are complete, a series of tests are conducted. The operator slowly extends and retracts the telescopic boom while observing the Y-guying system's response. This ensures that the structure operates smoothly and that the tensioning mechanism functions as intended. Final inspections are carried out to confirm that all locking pins are secure, hydraulic pressures are within normal range, and there are no unusual movements or noises. The successful installation of the Y-guying system marks a critical milestone in the crane's assembly. This system enhances the crane's lifting capacity, reduces bending stress on the boom, and allows for safer handling of extremely heavy loads. The assembly process of the Liebherr LTM 400-ton all-terrain mobile crane in the second part focuses mainly on connecting the telescopic boom with the Y-guying system and installing the ballast. Each step is carefully executed to ensure stability, strength, and precision for the crane's heavy lifting operations. To begin, the crane is positioned on a flat surface, with its outriggers fully extended and leveled to provide maximum stability. Once the lower structure is secured, the telescopic boom, which has been previously transported separately, is prepared for connection. The main boom is carefully aligned with the crane's superstructure using hydraulic guidance. Operators ensure that the attachment points between the boom and the Y-shaped frame are precisely matched before initiating the connection sequence. Next, the automatic hydraulic quick coupling system, known as Likafix, plays a crucial role in connecting the boom to the Y-frame. As the boom is lowered into position, the Likafix system automatically connects the hydraulic lines without requiring manual intervention. This innovation greatly simplifies setup, minimizes the risk of errors, and saves valuable time on site. Once the hydraulic coupling is secured, the electrical connection is established through a single synchronized movement, activating the communication and control systems between the boom and the superstructure. This automation allows the crane to be ready for use within just a few minutes, demonstrating the efficiency and technological advancement of the LTM 400-ton model. After the hydraulic and electrical connections are completed, the Y-guying system, a distinctive feature of Liebherr's heavy cranes, is fully extended and secured. The Y-shaped frame, mounted at the rear of the boom, helps optimize lifting performance by distributing loads evenly and reducing bending stress on the telescopic boom during operation. The Y-guying arms are hydraulically extended and locked into their working position, ensuring that the system is ready for lifting heavy loads at long radii. This step requires careful synchronization between the crane operator and the assembly crew to maintain precise alignment and ensure safe locking of all pins and connectors. Once the boom and Y-guying system are properly connected, the next critical stage is the installation of the counterweight or ballast, which provides the necessary balance and stability during lifting operations. The LTM 400-ton crane follows the same proven ballast concept introduced on the LTM 1. Juni 1350, featuring 100 tons of basic ballast and 40 tons of additional ballast. This configuration ensures optimal stability even when handling maximum loads at extended boom lengths. The counterweight installation process begins with positioning the ballast base plate on the rear of the superstructure. The hydraulic ballast system, fully integrated into the counterweight frame, allows for effortless and precise mounting without the need for an auxiliary crane. Each ballast plate is then lifted and positioned automatically using the hydraulic lifting mechanism. The plates are stacked and locked into place by hydraulic pins, which are controlled directly from the operator's cab or by remote control. This modern system ensures both speed and safety during assembly, drastically reducing setup time compared to traditional methods. The hydraulic ballast attachment system also enhances operational flexibility. It allows the operator to adjust or remove sections of ballast quickly, depending on the required lifting configuration. The Liebherr design ensures that all components fit securely and uniformly, maintaining balance and preventing any unwanted movement during crane operation. Moreover, the ballast plates used on the LTM 400-ton model are compatible with other large Liebherr cranes, such as the LTM 1. August 500 and LTM 1. August 600. This compatibility significantly improves logistical efficiency for crane fleet operators, as it reduces the number of different counterweight sets needed across multiple machines. After the complete set of counterweights is installed and locked, the crane undergoes a brief verification process. Operators check the hydraulic pressure, ensure the stability of the boom and Y-frame, and confirm that the ballast is securely fastened. Once all parameters are validated, the LTM 400-ton crane is fully assembled and ready for operation. This meticulous process connecting the telescopic boom with the Y-guying frame and installing the ballast illustrates Liebherr's commitment to efficiency, modularity, and innovation. The combination of Liquefix automatic hydraulic coupling, integrated ballast system, and cross-model component compatibility enables faster setup, reduced labor requirements, and improved safety. Within just a short time, the massive crane transforms from a transport configuration into a powerful lifting machine, capable of handling some of the most demanding construction and industrial applications. The final installation process of the upper structure and boom system of the Liebherr LTM 400-ton all-terrain mobile crane. This stage marks the culmination of assembly, where the crane's full lifting power and reach are configured for operation. The process begins after the carrier and base of the crane have already been positioned and leveled at the worksite. The superstructure, which contains the slewing platform, engine, and control cab, is carefully mounted onto the carrier using the crane's own hydraulic system and assistance from auxiliary lifting equipment. Once the superstructure is aligned with the slewing ring, technicians secure it with precision bolts and locking mechanisms, ensuring perfect rotational balance. The connection between the carrier and the superstructure is checked meticulously, as this junction bears the entire load transmitted from the boom during operation. After the upper carriage is installed, attention shifts to assembling the main telescopic boom, which extends up to 70 meters and can be carried on the crane with a 12-ton axle load. The base section of the boom is first aligned and fixed to the boom pivot point on the superstructure. Hydraulic lines and telescoping cylinders are then connected, allowing the boom to extend and retract smoothly. Each section of the boom is tested for alignment and hydraulic pressure before being secured. The Liebherr design emphasizes easy installation through modular components, so the boom's individual telescopic sections slide into position with guided rollers and locking pins. Next, the Y-guying system is installed to maximize lifting capacity and stability. The Y-guying structure consists of two massive support arms and a hydraulic tensioning system that forms a triangular bracing frame at the base of the boom. These are lifted into position using auxiliary cranes and attached to the boom foot and upper frame. Once fixed, hydraulic lines are connected, and the tension in the guying system is adjusted according to manufacturer specifications. This system not only increases lifting capacity, but also reduces deflection in the long boom during heavy lifts. Following the main boom installation, the crew begins to attach the lattice-type fixed JIB, which measures 45,5 meters and can be optionally adjusted hydraulically between 0 grad and 40 grad. The fixed JIB components are laid out on the ground and connected using high-strength pins and bolts. Once pre-assembled, the JIB is lifted and attached to the boom head via the JIB pivot bracket. The hydraulic adjustment system is connected and tested, allowing operators to change the JIB angle efficiently during lifting operations. To extend the working height, an eccentric section including a 3.5 meter telescopic boom extension is installed. This component acts as a transitional adapter between the main boom and the lattice JIB, improving the overall geometry of the lifting configuration. The extension is mounted at the top of the telescopic boom and locked into place with mechanical pins. It provides a stable connection that enhances both reach and flexibility for complex lifting tasks. Once the fixed JIB and extension are in place, the team proceeds to attach the luffing lattice JIB, which can reach up to 80,5 meters. This is one of the most demanding steps in the assembly, as the JIB sections are long, lightweight lattice structures requiring exact alignment. These sections are first bolted together on the ground, then the entire JIB is lifted by an auxiliary crane and secured to the boom tip. Hydraulic luffing cylinders are connected to control the jib's vertical angle. The luffing system is tested for full movement range, ensuring smooth operation between low and high angles. After all structural elements are installed, The hook block and wire ropes are reeved through the pulleys along the boom and JIB. This step demands coordination and precision, as the rope arrangement determines the lifting efficiency and balance of the crane. The ropes are wound evenly, avoiding twisting or overlap, and the hook is tested by lifting a calibration load to confirm stability and synchronization of all systems. Finally, engineers perform a complete inspection of the upper structure, verifying the hydraulic circuits, electronic controls, safety interlocks, and structural bolts. Once confirmed, the Liebherr LTM 400-ton crane stands fully assembled, featuring a 120 Meter maximum hook height and capable of operating in multiple configurations. The dismantling of the Potain MDT 248 J10 tower crane in Russwil is a precise and methodical operation that requires skilled coordination between rigging teams and mobile crane operators. The process begins with thorough preparation, including the securing of the surrounding work area and verification that all power supplies are disconnected. Once the site is ready, the first step is the removal of the counterweights, which are located at the rear of the crane's counter JIB. These heavy concrete blocks are carefully lifted off one by one using a mobile crane and placed on the ground. Removing them first helps to reduce the overall weight of the crane and ensure stability during the following stages. Next, the focus shifts to the dismantling of the JIB and counter JIB, the horizontal structures that extend outward from the tower. The folding counter JIB is usually detached first to maintain balance, followed by the main JIB. Both components are lifted down with precision and placed in designated areas for loading and transport. This phase requires accurate coordination to prevent any swinging or torsional stress on the remaining structure. After that, the team proceeds with the removal of the mast sections. The crane's vertical tower is disassembled gradually from the top downward. Each mast segment is unbolted, lifted off by the mobile crane, and then placed safely on the ground. This step-by-step approach ensures that the center of gravity remains stable throughout the dismantling process. Finally, the operator's cap, which houses the control systems and electrical components, is detached and lowered. Once all sections are removed, the slewing unit and base are disassembled. Every component is then inspected, secured, and loaded for transport. The entire operation highlights technical expertise, safety, and teamwork. In dismantling a large tower crane like the Potain MDT 248 J10, the upgrading process of the Sombrio Bridge began with the construction of the pier, the south abutment, and the north retaining walls, providing a solid structural foundation for the new bridge deck. Once the substructure was completed, workers started placing the prefabricated deck panels along the main span with precision to ensure proper alignment. Following the deck panel installation, approach paving was carried out to connect the bridge smoothly with the existing roadway. Next, crews installed stainless steel reinforcing bars across the deck area to enhance corrosion resistance and long-term durability. Before the final concrete pour, several deck screed test runs were conducted to verify surface accuracy and ensure the correct elevation. Once testing confirmed proper results, concrete placement for the deck began, with continuous monitoring to maintain consistency and strength. After the deck concrete was poured, it was cured carefully under controlled conditions. Insulated tarps were then placed over the surface to retain heat and moisture, promoting proper curing and minimizing the risk of cracking. Following this, the approach slabs and the pier deck section were set in place to complete the structural continuity of the bridge. The final phase involved installing the parapet forms and reinforcing bars along both sides of the deck. After ensuring correct spacing and alignment, the parapet concrete was poured, completing the barrier installation and marking the final step in the bridge's structural upgrade. The Sombrio Bridge, Renfrew, was upgraded from a single-lane timber bridge to a flashy two-lane, 124 Meter long concrete and steel bridge on a new 1.2 Kilometer highway alignment. The new alignment was constructed to a 70 km height standard, with 3.6 meter wide lanes and 1.5 meters of paved shoulders. The new bridge was built in a staging area adjacent to the railway, allowing work to progress without disrupting train services. Engineers assembled the steel framework on solid foundations, carefully aligning sections to ensure accuracy. Reinforcements and crossbeams were added to create a robust structure capable of supporting heavy rail traffic. The deck was installed and secured, forming a complete bridge ready for installation. By preparing the entire structure in advance, the project minimized the time required on the active railway line and ensured efficient execution during the replacement phase. Once the new bridge was fully assembled, attention turned to the removal of the existing structure and installation of the replacement. First, heavy lifting equipment was brought into position, including self-propelled modular transporters. These specialized machines were maneuvered under the new bridge, raising it slightly off its supports. The massive structure was then carefully transported along a prepared route toward the railway corridor. Precision control was essential as the bridge, weighing hundreds of tons, was moved slowly into alignment with its final position. Meanwhile, the old bridge was dismantled and lifted out, clearing the site for the new installation. After the existing structure was removed, the new bridge was rolled into place and carefully lowered onto prepared abutments. Engineers conducted precise adjustments to ensure a perfect fit and secure seating. Once in position, the bridge was locked down, and final connections were made to integrate it with the rail line. This coordinated effort allowed the replacement to be completed within a limited time frame, minimizing disruption to rail services and ensuring the new bridge was ready for operation. The assembly of the Portain MDT 289L16 tower crane follows a detailed and carefully planned sequence to ensure maximum safety, balance, and operational efficiency. The process starts with the erection of the tower mast, which forms the vertical backbone of the crane. The tower is composed of modular steel sections that are connected one by one, using strong bolts and pins. Each section is lifted and precisely positioned by a mobile crane, then securely fastened to the previous one. As the construction of the building progresses, more mast sections are added to gradually increase the overall height of the crane, allowing it to stay above the working structure and maintain an optimal lifting range. Once the tower reaches the desired initial height, the slewing unit, also known as the turntable, is installed on top. This component is essential because it allows the upper part of the crane to rotate freely, giving the operator the ability to move loads horizontally in any direction. After the slewing unit is properly fixed, the operator's cabin is mounted. The cab contains the control systems and safety devices that enable the operator to manage all crane functions. It is designed to provide excellent visibility, comfort, and precision during operation. Following this, the JIB, or main working arm, is assembled and attached to the slewing unit. The JIB is installed in segments, and each part must be perfectly aligned to ensure stability and correct load distribution. On the opposite side of the JIB, the counter JIB is mounted. This section supports the crane's machinery such as the hoisting winch, electrical systems, and counterweights. The final step is the installation of the counterweights, which are carefully positioned on the counter JIB to balance the crane structure. These concrete or steel blocks prevent the crane from tipping while lifting heavy loads. After all mechanical and electrical connections are completed, the entire crane is inspected and tested to verify its safety and performance.